Hi, this is Mrs. DB, and in this video we're going to go over how to do some of the problems on Chapter 2, Section 4 on writing linear functions. So to start with, we have this table on 10 through 15, and it asks you to kind of complete the table as you go in order to write the equation of each line in slope-intercept form. And just as a reminder, slope-intercept form, let me grab my pen here. Slope-intercept form is of the form y equals mx plus b. So that's the way we want to write our y equals x plus b. Write them in this form. So the first row of the table just says to write whether they're parallel or perpendicular. So number 10 says parallel to, so that's parallel. And number 11, of course, will be perpendicular, and number 12 is parallel. So that just wants you to kind of make note of what ones you're going to be doing it with. Now, parallel lines, we've learned, have the same slope. So the slope of the original line, y equals 3x plus 4, 3 is the slope. The slope of the new line is also going to be 3 because they're parallel, so they'll be the same. A point on the new line, that's given in the question, passing through point 0,9, so we're just going to write it down. And then we're just going to plug those into the equation and write them. So y minus y1, we replace that with 9, equals m is 3, times x minus x1, that's 0. And then now we solve for y, so that we can get y equals mx plus b. So y minus 9 equals 3x minus 0. We could do the distributive property there, but we'd get 3x minus 0, so that's just 3x. And now I just need to add 9 to both sides. And you can do this on your own paper and then just write what your equation would be. So y equals 3x plus 9. So that's all I do for number 10. And number 12 will be the same thing because it's parallel. You might have to do a little more work solving because you don't have a 0. But let's look at number 11, which is perpendicular. Slope of the original line was 5/9. So perpendicular to that will be take the reciprocal and take the opposite sign. So the original was 5/9, so the new one will be -9/5. The point on the new line is 0, -4. And then we just plug them into the equation, y minus y1. It's y minus a -4. That's interesting. The slope is -9/5. X minus x1 is 0. And now we simplify that, and we'll get y plus 4, because minus a negative, equals -9/5. Oh, we got that 0 again, x. And then we just have to subtract 4. And you'll have your equation. So if it's parallel, you use the same slope. If it's perpendicular, you use the negative reciprocal. And numbers 13, 14, and 15 are all the same. In 15, you might want to note that the slope, you might want to write that as 1/3. And if it's perpendicular, the reciprocal of 1/3 would be -3. Let's see, in 14, the slope is -1. The reciprocal of -1 is 1. That's already noted for you. And in 13, that's kind of like that too. Same note goes for 13. Except this time we're going to use the parallel anyway, so it doesn't matter, I guess. So you don't need that. Never mind. If it's parallel, you're going to use the slope of -1. And then you plug in your x1, y1, and you solve the same way. All right, I hope that helps find the equations of parallel and perpendicular lines. Thank you very much.